So all of you are here because there was no room in Brian Getz's talk, right? You laugh, but I saw that mob of people filtering in. It's a little scary. We still got a few people filtering in into this one, so I'll engage in that classic TV time-honored tactic of stall. How many of you are aware, Ed was just pointing out to me, that significant milestone in space history is about to happen during this talk? Yeah, it has nothing to do with me, unless I get kicked out of this talk, which is possible. Yeah, they're getting ready to land on a comet, which it's supposed to be, what, Ed, 5:02 p.m.? So at 5:02, Ed has promised to give us a thumbs up or a thumbs down. And if it's a thumbs up, we'll take a moment to applaud the people who made that happen. If it's a thumbs down, we'll blame .NET. I live in Redmond, so it's okay. These are my people. I get to make fun of them. So, out of curiosity, how many of you are architects? Show of hands. Okay. How many of you want to be an architect? Show of hands. Notice none of the people who raised their hand for the first one raised their hand for the second one. I'm an architect, but they made me. They gave me that title and I can't quit. So, those of you who did not raise your hands, why are you here? Seriously, there will be no code here. If you are hoping that I will talk something about Java 8, lambdas, functional programming, I'm not. It's like the only talk here at Devoxx that isn't around Java 8. So, all right, you have been warned. Here we go. This is me. If you don't know who I am, count yourself lucky. We'll move on. The interesting thing about this web thing that so many of us end up doing is that it really has kind of changed over the years. And one of the things, currently I work as a CTO of a small consulting firm in Seattle, Washington. And a couple of times people have kind of come up to me and said, so what exactly should we be doing, in terms of technology, in terms of approach, in terms of isms, right? What exactly should we be doing in the face of building a web application today? And it was an interesting question. It's one that I try to consider every so often, and I took a step back and I sort of surveyed all of the different things that are happening in terms of, you see people arguing concurrency models, you see people arguing messaging, and you see people arguing just because it's fun to argue. And I thought that I would take a stab at answering this question, and the result is the talk behind you. But one of the things that I find particularly helpful to do is I like to sort of take a glance back at where we have been in order to be able to kind of understand where we're going. Right? It's kind of useful to know the context and the history before we start trying to figure out, are we still doing that? Are we doing something different? Is it mostly the same, mostly different, so on. So, what I decided to do is conduct that sort of historical overview of the web. Now, some of you, if you have gray somewhere in your hair, some of you will have lived through some of this. Those of you who did not, you just have to kind of take it on faith that yes, it really did happen this way. Believe it or not. There was a point at which, we didn't all run around with mobile devices in our pocket. Speaking of space and technology evolution, did you know, fun fact, the iPhone in your pocket has more computing power than all of the computers used to put a man on the moon in the 60s. Think about that. Your iPhone running a lunar landing mission. How many of you are a little nervous about that? How many of you would trust your iPhone to keep you alive as you land on a rock 100 million miles away from home? Show of hands. Okay. How many of you would trust your Android phone? Yeah, there we go. All right. How many of you have heard of Xanadu? A couple of hands. Xanadu was the brainchild of another Ted, a guy by the name of Ted Nelson. And this was actually, there's a really good Wired article, which is where a lot of these quotes will come from, that talks about Xanadu and what he was really trying to do. And if you go back through the history, if you go talk to some of the guys who were involved at the very earliest stages and so forth, Xanadu was really, in many respects, what they were striving towards. This was kind of his brainchild, and in some respects, this was his white whale. This is what he kept chasing after and kept going after. And the Wired article contains the entire history, but this is like the early 60s. He wanted a word processor capable of storing multiple versions, displaying the differences between those versions, which is kind of interesting because, you know, unless you use a source control tool with your favorite word processing program, we still don't have that today. On top of this basic idea, Nelson wanted to facilitate non-sequential writing, in which the reader could choose his or her own path through an electronic document. In other words, he wanted to do away with the idea that a book is somehow linear, that you start at page 1 and you turn to page 2 and then page 3 and page 4 and page 5 and page 6 and page 7, page 8 and page 9 and page 10 and page 11. He hated that idea. He really wanted to let you, the reader, be able to jump around to various parts of the book to pick up on whatever was interesting to you. So he was really a big fan of, you know, what we now refer to as hypermedia. But at the time, we didn't have that term. And this was his brainchild, and this was his baby. And particularly during the 70s, he spent a lot of time working with a small cadre of very dedicated followers who kind of, you know, thought they bought into this vision. This is awesome. This is great. And then actually during the 80s, they got some funding and they went after this thing and so on and so on and so on. The longest running vaporware story in the history of the computer industry. Been in development for more than 30 years. Xanadu actually did ship a 1.0 about 5 or 6 years ago. And it sucked. There's just no other way to say it. It was pretty terrible. It's out there. You can go, you can Google it, you can get the Xanadu system up and running. And interestingly enough, for somebody who was so deeply enamored of the academia world, who was so deeply enamored of a lot of the things that you know, open source and so forth gave us, very little of the Xanadu code is actually available open source. As a matter of fact, they spent a tremendous amount of time keeping it closed on the grounds that there was this really, really cool file system idea that was somehow, you know, going to make all of this hyper efficient that they refused to publish to this day. So if you really want to know what's going on, you know, in Xanadu, it's very distracting having her taking pictures of you while you do this, by the way. I feel like I'm a fashion model. Anyway, Xanadu is not open source by any stretch of the imagination. And that's been one of its great criticisms. But one of the biggest problems with Xanadu was that Nelson had some incredibly overinflated ideas as to what this thing was going to be. I mean, listen to this. Meant to be a universal library, a worldwide hypertext publishing tool, a system to resolve copyright disputes. In other words, he was going to create a system whereby we would publish something into the Xanadu system, and it would be attributed to you, and anybody who ever used your material would know it was attributed to you, so you immediately had copyright. There was no argument here. And as a matter of fact, they could extract parts of your content, whatever it happened to be, and copyright would flow with it. Oh, but it gets better. A meritocratic forum for discussion and debate. So in other words, this hypermedia publishing system was somehow going to allow those who were best at arguing to be able to discuss, right, completely based on merit. We'll be able to have discussions, debates, by putting all information, not just some of it, all of it, within reach of all people. Xanadu was meant to eliminate scientific ignorance and cure political misunderstandings. Talk about very modest goals. On the very hackerish assumption that global catastrophes are caused by ignorance, stupidity, and communication failures, Xanadu was supposed to save the world. I mean, seriously, you could be finding out what Brian Getz is doing with Java 10, or you could be saving the frickin' world. Which are you going to choose? Right? You're on record. We have video. I mean, this is so very much 60s era computer science thinking that we are not just trying to do things that will cause a computer to add two numbers and come up with the right answer. We are literally trying to save the world. I really love the fact that somehow global catastrophes are caused by ignorance and stupidity. So the next time an earthquake strikes, you just need to talk to it. You need to understand why the earthquake is upset. And it'll just quietly calm down, and all the buildings that fell down will just kind of put themselves back together. Xanadu, there were some really interesting ideas that were buried inside here. And in particular, Nelson listed 17 rules of Xanadu. These were 17, you might call them features. They specifically called them rules. Every server is uniquely and securely identified. Well, we've got the unique part more or less, right? Thanks to the use of domain name systems and so forth, we can uniquely identify a server anywhere in the world. And if we ever manage to convince the world to adopt IPv6, we will have a better chance of uniquely identifying every server in the world. Can be operated independently or in a network. Well, we've got that, right? It's really easy to stand up a server on your own machine. It's very easy to do so across a network. Matter of fact, uniquely and securely identified is so important, we repeat it twice. Oh, no, wait, that's the users. The servers are uniquely and securely identified, but so are the users. In other words, Xanadu really did not embrace this internet ideal of anonymity. So if you did something on Xanadu, we knew who you were, and we had a very, very good belief. We had good faith because you were securely identified. How was never quite specified, but we knew who you were as you were operating on the system. Can search, retrieve, create, and store documents. We've got that. Each document consists of any number of parts, each of which may be of any data type. Well, we've got that, right? You can have text and you can have video, and does anybody care about anything else? Right? I mean, at one point, you know, sort of looking around the internet back in like 1997, I came to this brilliant realization that the internet is basically all 3270 plus porn. Because if you think about it, right, it's all those green screens, it's all text, plus the ability to have like video and sound, and we know where people went with that. Every document can contain links of any type, including virtual copies. Right? It wasn't just a hyperlink to the document. We can actually pull portions of your document into my document. So it was a transclusion. It was a copy of. It was a virtual copy of, because it would be a hot link. So if you updated the source document, all of the documents that were linked to that would also get those updates. And by the way, that also implied that the links were hot enough to realize that the source document was no longer there, and so on and so forth. Links are visible, followed from all endpoints. Permission to link to a document is explicitly granted by the act of publication. Well, we've got that, right? You put something up on the internet. The hard part now is taking it down. Google remembers everything. This is one of the best ones. Every document can contain a royalty mechanism at any desired degree of granularity to ensure payment on any portion accessed, including the virtual copies. So by linking to my document, you pay me. Now, who's down for that? Right? I mean, think about that for a second. Just by including that content, there was automatic, I could stipulate what the royalty mechanism was. I could say every time you transclude part of my document, you now owe me $10, right? Which I think works out to be about what, €3, given the current exchange rates? Isn't that about how it works out? What it feels like coming over here, let me tell you. All right. you begin to get a sense that Xanadu was really this thing which many people hold as kind of the brainchild. This is sort of the ancient ancestor of what Tim Berners-Lee was really trying to accomplish with HTML and HTTP. Xanadu had a bunch of things that were a part of it that still remain out of our reach today. But this was sort of that initial vision. This is kind of where people were going. This is sort of kind of the thing we were thinking we were trying to build as we started to build the web out in the 80s and then more importantly in the 90s and beyond. Every document automatically moved to physical storage appropriate to its frequency of access from any given location. That would be kind of cool, right? Your web page gets hit a lot. So it'll automatically move somewhere, like into cloud storage or CDN or something like that, so that's more quickly physically accessed. That would be awesome. Automatically stored redundantly, right? I mean, some of this stuff, you're just looking at this and going, really? They thought they could do this in the 60s, by the way. What do we end up with? Well, after Xanadu more or less kind of petered out, right? Towards the 80s, they got some funding, they went after this. In classic hacker fashion, they would start down a path, and then Nelson would have a brilliant revelation, and so they would throw away all that code and start over again. And then after they started to get down that path, he would have another brilliant revelation, and they'd throw all that code and start over again. So Xanadu kind of took this weird left turn off into irrelevancy. But there were some other folks who said, I don't want to lose this idea, and HTML, a subset of SGML, or I'm sorry, an instance of SGML, XML was the subset of SGML. How many of you knew that there were more than 2 MLs out there, by the way, right? We basically said, yeah, let's play around with this thing called the browser. Let's experiment with this hypermedia thing, right? And this was really the era of the static web page, GeoCities. How many people remember GeoCities? By the way, probably one of the best examples of this era's web. How many of you remember the movie Space Jam? Michael Jordan and the Looney Tunes characters, right? How many of you actually watched it? I watched it recently. It was just as bad as I remembered it being. Did you know that the Space Jam website is still up? It's still online. I'll prove it to you. Assuming I have internet connectivity here. I looked it up earlier, but there you go. Now be honest, how many of you built a page like this? Yeah, all the youngsters are like, no, that's not real. No, seriously, right? You know, we could, you know, this is all client-side image maps, right? So based on where you clicked on this image, you got taken to a different link. Look, we've got the... I couldn't make this shit up if I tried, guys. I mean, seriously, right? If you were not yet born in like 1995 or whenever it was when this movie came out, just trust us. It was legit. Let's see. The frames, right? We've got more image maps here. Somewhere in here, I'm sure we've got a blink tag. Right? Click on that. Oh yeah, now we've got the thing down the side, right? How many of you are like, please stop. Just make the pain stop. 2 years of therapy and now you're bringing it all back. Just stop. This was the web. This was the web back then. This is what we built, and we were proud of it. We were young. We needed the money. It's okay. Forgive yourself. And then, right now, this, technologically speaking, this was all static HTML, right? This was a page. The 3 guys in the front row going, oh dear God. I remember. This was all static HTML, right? These were frames. That's how we sort of segregated the different parts of content. And a lot of these were images, right? And this was the era of the home page. This is when being online meant you had a static page on the internet that other people could browse and look at and read about. But it was, all the interactivity was limited to what was happening in this page, which is part of the reason why we went so freakingly, stupidly deep on having like blinky things and having image maps that took you over to other parts of this same site, took you over to other files. This is, you know, I mean, for 1997 or whenever this was pretty cool back in the day. But the problem is it was completely client-side interactivity, and there was precious little of that as it is. You won't see a lot of the things that we expect in terms of some of the various, you know, we might expect some tooltips that would pop up here, right? We might expect to be able to, you know, link within the document. We didn't really do any of that stuff. The best we had was this, like, you know, menu nav bar over here on the left, right? We can click here, et cetera, et cetera, et cetera. And then people started wondering, you know, it would be kind of cool if somehow the server could communicate to the browser in some fashion. Now remember, HTTP, I mean, what we see today is the same HTTP we were using back then. And so it's still a client-initiated request-response protocol. So people were trying to figure out how would we, in fact, interact with the server. If I wanted, because this was a thing, if I wanted to know how many people viewed my web page, right? How could I do this? Well, then people started to hit on the idea that each time I pull one of these images, that's another HTTP request. So what if I have an image that actually isn't an image, that is in fact talking to something on the server? And this was when we started doing CGI scripts. Right? Common gateway interface, talking to either a Perl script or a Bash script, you know, and the Bash script, of course, once it's executing on the server, it can do whatever you want it to, right? Perl, of course, never actually really runs, it just pretends to, so we'll leave Perl out for just a second. But Bash, I mean, you have full control over whatever you wanted to do in that script. And yes, there were some people who said, yes, we could write this CGI thing in C++. They're still working on it. Someday it'll work. Point is, you could do whatever you wanted on the server at that point. And people started keeping track of the number of times this page was hit. They started taking form submissions. They started doing some things to try to pull a little bit more of that interactivity, store it, and be able to display it back to the user in some fashion. Which is where we started getting to more of this simple server saying, all right, I want to be able to do more things on the server. As soon as we were able to start executing on the server in response to an incoming request, people started, of course, thinking like, well, wow, I do have all of this really cool company data stored here in a database that I'd like to be able to display. So we started building tools that would, you know, the request would come in and either directly, you know, the Bash script would directly find this data and hand it back, or we started thinking about maybe we can sort of combine these two. Why do I have to make all of these multiple trips back and forth between the browser and the server? Wouldn't it be cool if we could just make kind of one trip out of this? Let's take our CGI script, let's take our ISAPI, NSAPI, etc. Remember, back in the day, you know, web servers were actually a commodity market. Right? Microsoft had a web server, Netscape had a web server, O'Reilly had a web server. Anybody remember that? O'Reilly actually sold a web server because they were convinced that that was the future of publishing, that you would want to buy your own web server and stand it up. I mean, it's kind of silly today. You look at the HTTP protocol and you're like, yeah, I could write that in a weekend. But this was, you know, we didn't realize it back then. This was something that only the big companies did. And so we started building all those plugins to give us more of that dynamism. And then we said, you know what? This HTML thing is, you know, it's kind of cool, it's kind of nice, but I can't do much inside the browser, right? It really is 3270. I get that thing back, I display it, but I want to have like animations. I want to have responsiveness. I want to be able to swap out a page and swap something else in dynamically without having to make another round trip back to the server. I want more control on the client side. Well, at this time, JavaScript was a non-starter. As a matter of fact, in the era around 97 or so, if you walked into certain places and said, I want to build a web app using JavaScript, you were told very bluntly, no, JavaScript is a security hole. And as a result, we're going to use ActiveX. That was actually US government policy, by the way. Not just big. It landed? It landed. Love science. All right. It's kind of frightening that we're talking about landing a thing on a comet at the same time we're talking about ActiveX, but yeah. Anyway, so at this time, right, people said, I want to have more activity in the browser. I want to have more control over what goes on in the browser. And this was the era of the Java applet. Now, the applet had the great advantage, which is that it was running inside of a sandbox, security was a big deal, et cetera, et cetera. But at the same time, this was a plugin that had to be supported by the browser. This was the argument that Microsoft made around ActiveX. Look, it's just another plugin. And Adobe, of course, came around and did Flash. And then, you know, Microsoft, they couldn't get ActiveX to work. So like 10 years later, they released Silverlight because this time we're going to get it right, damn it. The whole point is we want to do more things in the browser. We want to be able to execute more things in the browser. We want to have more control over what happens in the browser. And that was pretty cool, but it turns out that if you want to do anything really non-trivial, I mean, no matter how many animations and so forth you do, you often want to have access to the data that's still residing back here on the server. And so we started coming up with some really, really interesting architectures where we would create a page that would host an applet that would in turn get loaded into the browser. But now the applet needs data, so the applet would make a Corba call back to the same server, and that server would then go query the database, bring that data back, and come back to the applet. Winning. Or in some cases, and this is where we started getting into the various different type drivers, depending upon whether you were doing this across the public internet, or whether you're doing this across a private intranet, you could actually have a native driver that could be signed, which could then use native code to call directly over to that database without going through the server in the middle. This was state of the art back then. And at some point, we stopped smoking whatever it was we were smoking and said, wow, okay, no, this is not working for me. Let's try something different. Let's actually try creating all of the UI on the server directly, right? So now the request comes in, and when the request comes in from the browser, we literally piece together the HTML that we want to send back to the browser. And when the browser says, okay, it's now time to do something else, we would again assemble data out of the database. We would again assemble various parts from here. Originally, these were just servlets, and the HTML was embedded directly inside the servlet code. We said, that sucks. Let's actually segregate this out. Let's take the model view controller pattern from Smalltalk. Let's bastardize it in a couple of ways. We'll call it MVC, even though it's really not. And then we'll use JSPs to do that. And then Struts came along and said, JSP sucks, so we're going to give you something that looks exactly like JSP, but it's different. And we reinvented that like 4 or 5 times, right? Ruby and Rails came along, did the same kind of thing. We've had all of these various MVC, all basically doing the same thing. Take data, assemble it, mix it together with HTML, ship it back over the browser, there you go, enjoy. And it was good. Except, other people said, that's great that you've given me a UI to do that, but I'm not interested in using your UI. What I care about is your data. I don't care about your UI. All I care about is your data. And a small black market industry grew up around how to screen scrape HTML, right? You're a startup, you're a scrappy young startup, you want to figure out how to make it easier for people to fly from one city to the next. You don't really want to try to negotiate Byzantine deals with each of the airlines. So what you're going to do is you're just going to go hit their website. You're going to go study exactly how they've laid out their HTML. You're going to scrape the data out of their HTML so that you can present it in your own UI to the users. That way you get to pocket the extra money and not the airline. And eventually that turned into, wow, this is really a data integration opportunity. Lots of companies started to realize that it's actually better if I give you a blessed way to consume my data as opposed to trying to prevent you from scraping the screen, because you really can't stop them from doing it. It's better to have a program to let them do that. More importantly, we start to enable things that wouldn't have happened otherwise. We start seeing people build things out of these new data APIs, et cetera, et cetera. So now we started to see it'd be really cool if we just had APIs that delivered data, and then we'll actually use HTTP to consume that data, and we'll start to build other clients. Not surprisingly, this is around the same time that the mobile stuff starts to get big. Originally, we walked into the mobile world saying we're going to build mobile websites. We're going to do m.yourdomain.com. Or we're going to use, actually before the M.dot convention, there was actually a couple of efforts to do a very, very stripped down version of HTML that was specific for the mobile stuff. WAP, I think it was called, Wireless Access Protocol, or something along those lines. And, you know, it was a complete disaster. And eventually we just sort of settled in on, you know what, how about you just make your data available to me? Let me just expose the data to you in very well understood ways. I'll still have a website, but if I'm really doing this correctly, my website will consume these same APIs. And now we're starting to see these various startups really take this, you know, Yelp and some of these other companies. For the most part, they're just an API, and they slap together a user interface. There you go, guys. Have fun. But we're really selling you APIs now as opposed to a website. And we're still not at the Xanadu vision by any stretch of the imagination. How many of you have ever clicked on a hyperlink and had it go nowhere? Yeah, the rest of you are just tired of raising your hands. Somebody got paid to do this. Somebody conducted a study where they just tried to estimate the number of bad links across the internet. They estimated it somewhere between 30 and 40% of all the hyperlinks on the entire internet are bad. Link rot is still a problem that we have to deal with. Now, ideally, the browser would somehow send something to the server to say, hey, by the way, I tried to go to this link. But what you really want to do is you really want to go back to the page that sent you there and tell those guys, right? Yeah, there was an attempt to try to do that. There was a convention. If there is a bad link, browser should go here. It didn't go anywhere. There's no integrated or universal identity system. We're still kind of feeling our way around that one, right? OAuth is one such effort. There have been others. Anybody remember when Microsoft was going to stand one up called Hailstorm, right? The idea was that all of your authentication credentials would be stored with Microsoft. Microsoft, in turn, would be sort of a federated access portal to be able to log into a bunch of these other things, blah, blah, blah. Everybody said, oh, that's terrible. Then Google stood one up, and we all said, that's okay. Because Google would never do anything bad, right? It says it right there in the motto, do no evil. Anytime the doctor says, trust me, I'm a doctor, get a new doctor. And the Xanadu thing was really only for hyperlinked documents. This is one of the interesting things that has happened over the years. When we talk about Xanadu, everything was centered around the idea that this is hyperlinked data. This is hyperlinked content. It's not for doing a lot of the things that we are trying to get it to do today. If I want to be able to buy things, sell things, etc., that's not really the spirit of what Xanadu was trying to do. All of that royalty commission thing to one side. Amazon.com doesn't exist in Ted Nelson's view of the world, right? if I want to be able to do some of the big data processing that we're starting to see emerge, if I want to do some of the data visualizations, yeah, it kind of sort of fits in, sort of. But certainly, if we're talking about your company's domain, right? If you work for Best Buy, and your job, your website is basically there to convince people to come in and buy stuff, or better yet, buy stuff online over their online e-commerce program, we're not really talking about hyperlinked documents much anymore. That may be the delivery vehicle, but that's not really what this technology was designed to do. And Roy Fielding, the guy who coined the term REST, representational state transfer, it's his dissertation from which we got that term. Roy has made it very, very, very clear on any number of occasions, to the point where he's sick of tired about it. He won't talk about it anymore. He absolutely refuses to engage this debate anymore. He says, representational state transfer, if you are not using Hypermedia as the engine of application state, you're not using REST. In other words, if you're not storing the current state of whatever it is you're doing in a Hypermedia document, you're not doing REST, the end. That's going to make a lot of people cringe, because we're like, oh, well, I'm doing REST, and you hit me with a request, and I send you back XML. Okay, is the state, is where you go next with this data embedded as a part of that XML? No, 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 no. The XML represents a resource. It's just the data for that resource. Okay, you're not doing REST, according to Fielding. Now, does that mean what you're doing sucks? Oh, hell no. Because I firmly believe that we have moved to a point where we are actually getting beyond what the originators of this thing intended. I think that we are reaching a point where we are about to leave behind the original preconceptions of what the web is, what it was supposed to be, and move into something different. It still is a lot of these things. In many respects, the web is still very much a consuming resource, right? This is a great website. It will consume far more of your time than you ever thought possible. Says the guy who's supposed to be working on his slides tomorrow. Right? Take me to a useless website. Okay, that's enough of that. That is still possible. That is still doable. You can still build those kinds of applications where they're still very consumable, very hyperlinked, et cetera, et cetera, et cetera. Not to say that those aren't even useful. Well, no, it says useless website. But you get my point. We are really reaching sort of the limits of where our forefathers really thought the web was going to be and what it was going to do. And that's okay. At a certain point, children have to leave the house. They have to make their own decisions. What mom and dad thought was good for you may or may not have been, right? My mother actually thought I should be a priest. The fact that some of you are laughing at that concerns me just a little bit. The fact that most of you aren't concerns me even more. Yeah, at a certain point, it's time to grow up and leave the nest. It's time to start making your own decisions and start realizing that maybe what they thought should happen, maybe the way that they thought things should work. My mother was actually very concerned when I came out of college and immediately started getting into software contracting. I never stayed at any one job for longer than a year. When she came out of college, the goal was to go find a nice company and work there for 25 years, retire, get the gold watch, happily ever after. The model changed completely out from underneath everybody. It's a different world. And we're reaching that point now with the web. It's something different. So when we start talking about modern web architecture, what are we really trying to get after? What are we really trying to do? Okay, let's take the terms apart, right? Architecture, set of predetermined answers to the questions that developers will ask. This is basically all an architecture is. For example, if you work at Amazon or you work at some company that's in a similar vein, and your job as a developer is to calculate the tax on a particular bundle of goods, there are a bunch of questions that are going to come up as you try to implement this feature. Where do I find the bundle of goods? Do I have to look it up out of the database, or is it stored in memory someplace? Okay, if it's in the database, then do I create a new connection to that database? And if so, where do I get the credentials for it? If the connection already exists, where do I find that connection? And when I'm done with it, do I close it, or do I just leave it be, put it back, however you want to think about it? What about where I'm delivering this to? Because frequently tax, particularly in the US, depends on where it's being delivered to. You have to use the tax rate of the state, county, city, wherever, where you're delivering it to. Or if it's going across international lines, are there any particular customs? So I need to know the shipping address. Again, do I get that out of the database? Is that somewhere in memory? Et cetera, et cetera. All of these are questions that are coming up. And an architecture fundamentally answers a lot of those questions. Because if you don't have an architecture, developers will answer it for themselves each individual time. And they will often do, as any of us would, they will often do what's easiest for them at that moment, which is how you end up with a website that makes 22 different database calls just to find out what the user's first name is. And of course, that's not going to scale. So it's a set of predetermined answers. Web. Let's be really blunt, guys. The web is now synonymous with internet. Those two terms are exactly the same. I don't care if you are actually using HTTP and HTML in a browser. If you are on the web, you could be on the, we're calling it the mobile web, when your phone is able to connect to the internet and download some data. Web equals internet, end of story. So if you're doing anything that's online, connected, etc., you're on the web. Modern. Meaning, I won't be tempted to rewrite this in 5 years. All right, let's be blunt. You're going to be tempted to rewrite it in 5 years. Because Brian Gatz will be talking about Java 12 at that point. And you'll be like, oh, this is going to be so cool. Hey, boss, we got to rewrite it all. Right? But I mean, think about for a moment all of the software systems that were built in the 60s that are still running to this day. Like your bank. Guess what they're written in? It's not Java 10. Starts with a C and ends in OBOL. And it still runs. The biggest problem, the biggest threat to COBOL that people are facing today, all the COBOL programmers are dying off. If you're really getting tired of chasing this constant churn of technology, there are some COBOL books that are calling to you. That shit hasn't changed in 40 years, right? So if we want something modern, means we want to keep it around for at least a certain length of time. Whether or not it needs to live for 50 years, yeah, we could debate that. But we want it to not be something that we have to rewrite 2 years from now. And let's be really blunt. If you're working with, right, still going, I love it, right? But if your company website looks like this, and that was just, what, 15, 20 years ago? If your website looks like this, okay, A, get a new job, right? But B, you're going to have to rewrite all of this. There is literally nothing here that you will be able to reuse in any way, shape, or form, except maybe the HTTP protocol, right? This is not what we would call modern by any stretch of the imagination. Oops. Yeah, there we go. So that's basically what we're talking about in terms of modern web architecture. It's a little vague, so let's talk about some of the things we'd prefer to avoid. Because there are some very common fallacies. These are mistakes that everybody makes. Peter Deutsch, back in, I think it was the late 80s, wrote a talk. The slides never appeared. It was an internal talk given at Sun. And in it, he talked about the 5 or 6 fallacies of distributed computing. Well, this talk has kind of continued on in legend. James Gosling had this list off of his webpage for a while he was at Sun. He added number 8 to that list. Other people have added a couple of the things. I added number 9 and number 10 because I'm just arrogant that way. The network is reliable. How many of you are on the conference Wi-Fi? You know, right? But this is a very common mistake that we often make when we're architecting a system. We assume that the network will always be present, because if you didn't assume, then you would write the code necessary to deal with the fact that the network could disappear in between one iteration of the result set and the next. You know that really, really nasty SQL exception declaration that occurs inside of JDBC that you always have to put this try catch around? And you're so sick and tired of doing that, that after about the third time it shows up, you're like, whatever, catch, SQL exception, curly brace, right? This should never happen, is the comment that goes right there in the middle of that, right? And then when it does, you're like, well, it wasn't supposed to happen, right? Because it will always happen. Werner Vogels, the guy who's the CTO of Amazon, who knows a few things about doing things at scale, says, quote, anytime you talk about something happening once in a million, you're talking about it happening next Tuesday. Because at the number of iterations, the number of transactions that Amazon is trying to run on a daily basis, every million transactions really does happen somewhere on a weekly basis for them. So if you have an error that only occurs once in a million, it is going to happen. It's just a question of when, not if. How many of you are prepared to deal with errors like that? Most of us aren't. Most of us are like, When it happens, I'll put it into this log file, and ops will deal with it. The people are laughing are the ones that their ops people hate them. Latency is 0. Bandwidth is infinite. The network is secure. Topology doesn't change. These are all fallacies. These are all things that if you say them out loud, other people will look at you and say, you're out of your mind. And then we go off and we use technology that embraces these fallacies, right? Think about Corba for a second, or any other distributed object technology, which assumed that the network would always be there. I'll just make this call against this distributed object and it will always be there. Well, what if the object's not there? Well, that'll never happen, because nobody will ever turn that machine off. Nobody will ever watch that router explode into flames, which has happened personally once. Nobody will ever be working at a company whose internet service is provided by a cable outside the building that a guy with a jackhammer shears through. You laugh, it happened to us in Redmond just 2 months ago. Some jackass with a jackhammer was outside the KFC and was doing some construction work and cut off residential internet access to all of downtown Redmond, Washington. Now, would you like to care to guess what kind of people live in Redmond, Washington? They all have email addresses that end in Microsoft.com. It was out for 2 weeks. 2 weeks before they could actually somehow take this part of the cable and this part of the cable and go, Don't ask me why. Don't ask me. You could not use a credit card at any of the downtown businesses, and you can tell I'm still bitter. Very, very angry. Everybody makes these assumptions, all right? You have made these assumptions at various parts in your code. So if we're going to talk about a modern web architecture, these are things that we really want to take into account. We want these. Ideally, I would have them as you walked out the door, right? As you go by the little, how did you like this talk? And you're hitting the green thing, right? You're going to hit the green thing, right? I have a bet with Venkat Subramaniam, so you're going to help me with this, right? Because otherwise I have to eat vegetarian and that doesn't end well. As you're hitting the green thing, I would tattoo these 10 fallacies across your forehead so that every time you looked in the mirror in the morning, you would see them and be reminded of them. Take a photo of this, print this out, whatever, put it up in your cube. Don't make these mistakes, okay? That's the best architectural advice I can give you, regardless of platform or technology. What do we want at this thing? Well, we want it to be modifiable. We want it to be extensible and scalable. We want it to be able to evolve. We want it to perform, right? Both in terms of actual performance, how long does it really take, as well as the perception of. Reliability, composability, securability, interoperability, discoverable. Well, kind of, sort of. We went down this discoverability route with the whole web services space. You remember WSDL? You remember how great that was? The whole point of WSDL was so that tools could consume a web service. And it turns out that trying to describe a web service in all the various incarnations in which we can build one, that turns out to be a lot harder to do than we originally imagined. And so we basically said, yeah, if you want to discover my website, if you want to discover my web service, if you want to discover my web API, you email me. That's how you discover it. You guys laugh, but that's what you're doing. Oh, and now there are some efforts now to try to create sort of a JSON schema. So I'm waiting for JSDL, the JSON description language. You wait, it's coming. Somebody's working on it right now. All right? Yeah, anyway, we don't have to imagine what that looks like. Oh, and of course that last bullet point down there is kind of important to you guys over here, right? Over on the other side of Atlantic, we just assume everybody speaks English. Over here, though, I don't know how well that works. So being able to internationalize some of this stuff would also be good. What are we really trying to do? I call it platform-oriented development. Pod. You're trying to build a pod. You're trying to build a platform. A platform is different from a web app in that the platform doesn't really assume a whole lot about the client that's consuming it. There are some things that the platform will enforce on the client, but for the most part, the platform says, I am here, I provide some access, I provide some context, I provide some data, I provide some behavior, I provide a whole bunch of things. So what do I mean by this? What is a platform? In the most general sense, whenever a pre-existing environment, a piece of software is designed to run within, obeying its constraints and making use of its facilities. Typical platforms include hardware architecture, operating system, and runtime libraries. Yes, we can talk about the Linux platform, we can talk about the Windows platform, the Mac platform. That's a little bit larger scale than what I'm really imagining. Set of subsystems and interfaces that form common infrastructure, on top of which a set of related products are developed. This is getting a little bit closer, because now we're talking about the idea that a platform is really built around a concept, an idea, a domain. Whatever it is you do, whatever it is your company, to be more specific, does. If you work for an online travel agency like Orbitz, what you do is you sell plane tickets. That is your domain. And yes, there's going to be a lot of infrastructure that you're going to be using. And not surprisingly, a lot of your infrastructure may look very similar to the infrastructure that your competitors are using, or the infrastructure that people that are completely unrelated to your domain are using. You're building software to sell plane tickets. Those guys are building software for hospitals. There is no domain overlap here, and yet a lot of your infrastructure will look very, very similar. Set of components, services, or interfaces designed for developer consumption. That, to me, is the key thing when I'm talking about platform. Yes, consumers, normal people, not us, will want to use your platform, but they will always do so through some client interface. They will do so through a browser. They will do so through some sort of native application, something running on iOS, something running on Android, something running on the 4 BlackBerry phones that are still out there in the wild, right? They will be running it through some particular client perspective, but what we're building, when we're building a platform, we're building it for developers. We're building it for other people to consume in that way. If you're not a developer, sure, here's our website. And our website, built by developers, consumes our platform. But we may make a conscious decision to not expose certain parts of the platform, because if you're coming to our website, you're probably not a very sophisticated user. We don't want to show you all of the complexity, et cetera, et cetera, et cetera. Platforms. Windows, of course, is a platform, right? Again, that's more of an operating system level platform, but it fits this idea. If you look at the Windows operating system, or the Mac, or Linux, they provide a set of APIs. They provide a set of tools for developers to use to build stuff so that other people can get stuff done. Salesforce.com, Facebook, Twitter. Facebook and Twitter are examples of this web platform. If you've ever tried to build one of these Facebook applications, they have a very extensive platform, and they have some very specific rules about how you interact with it. Obviously, iOS is another such platform. Android is another such platform. Part of the thing is we know how to build these things if we're building them for developers. Ever wondered why there are so many different logging frameworks in Java? Right? You're getting ready to build something for the company, and you need like an application that understands how to do hospice care. And so you start cruising through the open source community looking for hospice care frameworks. How many of those are out there? Right? I'm waiting for some guy from Apache in the back to say, I've got one. It's written in Smalltalk. Right? There's nothing. There is no domain vertical open source software. Why is that? Because developers, we don't know shit about hospice care, but we do know about logging. We know logging because we've had to do it. And do you know what? All those other logging frameworks, they're doing it wrong. So what do? We build one because we know how it should. See, if it's a developer-oriented thing, we understand because we're developers, right? We have that impression. We have that mentality. So it becomes much easier for us to build something that's developer-oriented because we're basically building it for ourselves. Now, in some cases, these platforms are going to be very domain-centric and focused. If we look at Twitter, Twitter is built. Their platform is built around exactly one thing: being able to send and consume messages of less than 140 characters. Everything else that Twitter offers you is built around that one concept. Everything that Instagram offers you is built around the concept of being able to see what your friends had for lunch. Right? Because that's all Instagram is good for, right? Pinterest, I just want to be able to pin what people find interesting, et cetera, et cetera. There's a single concept there. Salesforce is growing much, much larger, but theirs was built around basic CRM. That's what their core platform was about to begin with. In some cases, you may build a platform that stretches across platforms. If you are building some tool that is designed to help your company interact with its community, your platform may in fact stretch across Twitter and Facebook and Salesforce, etc., to be able to make it easier for your people to interact with the customers that are out there. If you fly on Delta Airlines, they have a Twitter account. If you tweet to @Delta, somebody, one of their customer service reps will respond. I guarantee you they don't have 27 people sitting around in folding chairs looking at their phones waiting for the Twitter client to beep at them. They built some software that provides that kind of capability. They built a platform that incorporates somebody else's platform. Practically speaking, what am I doing here? So it's a number of different things. It's a communication backplane. That's going to be a key part of this. That communication backplane ideally will be interoperable. It will be something that can stretch across a variety of different hardware platforms. Ideally, it will stretch across Windows, Mac, Linux, etc., but also iOS, Android, and so on. It's a set of data types and entities. Most of the time, your platform deals around a particular concept, a particular domain. So again, if you are a company that sells tickets to people, right, sells airfare, these data types and entities will be around bookings, planes, trips, airports, destinations, length of trip, et cetera, et cetera. All of these will be your data types. And you will expose these to outside consumption, to the developers that will consume your platform. It doesn't have to be an industry standard. It's probably better if it isn't, because you're going to want to offer certain value-add features that your competitors don't have. One or more data storage environments. Those data types have to live somewhere. And in some cases, you may want to expose that data storage environment directly to the people consuming your platform. In some cases, you may not. This is going to be kind of a, it depends on what exactly you're trying to enable. Shared execution context. Meaning, when you access this part of this platform over here, we understand that it's all related to this larger concept of airline tickets. So that if you're looking up a customer, it's a customer specifically to our company. or it's a customer that's shared with one of the major airlines, and there may be an airline locator, and that airline locator record may be something that's understood to be meaningful to that other party, to that other airline. Implicit or explicit versioning strategy. What happens when we want to change this? You have to be clear. You have to tell people. In the REST approach, we try to make that explicit, unless you're one of those people who argues with that approach, in which case you say the versioning should be implicit. It's where we get into discussions around semantic versioning. I don't care what you're doing. I don't really care how you handle it, as long as everybody who consumes your platform knows how you're handling it. When we release a new API, you know because. When we deprecate an API, you know because. When we decide to turn one of our systems off, you've been warned, right? There will often be some kind of shared security context. Can be as complex as something like OAuth, can be something as simple as username, password. Whatever it is, however it works, I don't care, but it's part of your platform. You need to take care of it. You need to be explicit with it. Usually, if you have data types or entities, people want to be able to see that data, which means you want to be able to report on that data, consume it in large fashion. Show me all the customers who've bought tickets with us in the last week, month, year, whatever. And then, those are just kind of the basic infrastructural things. Then we start talking about what actual features your platform will offer, right? Your platform may be about trying to do social airplane travel. Maybe this is a platform designed to help you find your friends who are traveling to the same cities as you so that you guys can work out, hey, we're all going to be in the same place, let's get a car from the airport, et cetera, et cetera. Does that mean that this is just a set of APIs? Kind of, yes. At the end of the day, everything really starts to boil down to just a set of APIs. You could argue that the servlet API is just a set of APIs. But no, because there are business-related domain elements here. There ultimately has to be some business stuff here that people will actually want to spend money on. So it's more than just APIs. It's APIs plus value. And it's usually executed inside that known context, which may or may not be defined by an API. I may put an order into Amazon, and Amazon takes that order. And what happens next is entirely outside the realm of API. But when Amazon takes that order, after a couple of days, a brown box shows up on my doorstep. That's completely outside of the API's control. That's part of the understood shared context of how the API works in this particular case. Does it have to be HTTP? Doesn't have to be. If you can get all of your clients to agree to do this over a messaging-driven backplane, Apache Camel or AMQP or something along those lines, then yeah, you don't have to use HTTP. Since we often talk about interoperability though, HTTP is the one protocol we all have kind of agreed on. So that's going to be the one you reach for first, unless circumstances take you somewhere else. How does it relate to SOA and some of these other micro and pico services? And I'm fully convinced that there will be nano and other sorts of even finer grained services. You know what? At the end of the day, a platform in many respects is a service. It's a collection of services. It's a collection of services that are bundled together under one sort of domain type concept. Remember, there's going to be some common infrastructure there that are often going to be made up of services. If, for example, you decide that you want to defer all of the authorization and authentication in your platform to a third party, there's a great company here, Auth0. Okay, great because I know the founder. He used to be a Microsoft guy, lived in Redmond. Eugenio's a great guy. But if you defer to them, that's a service, but that's not something you're directly exposing to your platform. Does that mean you're building a service? Does that mean they're just a service? Are you a service of services? I don't care. You're building a platform. The platform will be made up of a lot of different implementation details. And that's going to be the theme for a lot of this that comes. I don't care. Implementation details outside the platform boundary, or implementation details inside the platform boundary. When you're standing outside the platform boundary, I shouldn't care. The communication backplane should hide a significant amount of that from me. Should I do messaging or event bus systems? I don't care. I really don't. It's an implementation detail. Just tell me how to send you data. And your API may change slightly based on how you approach this. But I don't really care one way or the other. Cloud. You know what? You give me an endpoint. Tell me where that endpoint is. I don't know if it's on-prem or if it's remote. It's the beauty of network transparency. Functional, object-oriented, resource-oriented. All of them. Use all of them. Use whichever makes sense for the particular kind of platform you're building. If you look at Amazon, in many respects, it is very much a functional interface. I give Amazon money, I get something back. You could say, well, that's a side effect. Yeah, or you could think of it as a transformation that takes money and turns it into crap. I don't know. However you want to look at it, it works. Then we get into some of the command query responsibility separation or event source. These, again, implementation details, they may influence the way you build your platform, the way you expose it to your developers. But choose one, choose both, don't choose either. It doesn't matter. The platform defines that. You're building all of that context. Then we start talking about the client side, because everything that I've been talking about has been server side. The client side, does that mean everything's going to be web? Oh, hell no. If you're not doing something on some of these mobile devices today, you're missing out on a huge amount of your potential customer base. So yeah, all of these different clients are going to be out there. That's why you need to build the platform in the first place. If it was just web, you wouldn't need APIs for other people to call because you'd be doing all of that on the server as part of that complex server processing. But you do need other clients. They are a part of what you're trying to do. The web that we see today very much is a modern web architecture. The web that you're building today very much is this stuff. You've been kind of fumbling and stumbling your way towards it. We have slowly evolved our way to think about web APIs. Next step is really to say, okay, an API doesn't stand alone. It sits inside of a shared execution context, and it should behave when it does these things, and we're going to expose these data entities and so on and so on and so on. If we go down this path, if we continue down this path, and I see no reason why we won't, you will be building platforms over the next 5 to 10 years. So in my opinion, just embrace it and enjoy it and watch as everybody else struggles to be where you are now. Bye-bye.